Our story begins with the universe's first dramatic expansion. From an intense burst of energy, matter cooled and coalesced into clouds of gas and dust. Over hundreds of millions of years, gravity molded those clouds into a young sun and a spinning disk, the birthplace of planets. Within the disk, dust and rock stuck together, forming planetesimals that collided and merged. Repeated impacts and intense heating produced a partly molten early Earth, setting the stage for internal differentiation and the separation of core, mantle, and crust. On a young planet cooled enough to hold liquid water, chemistry took an extraordinary turn. Organic molecules concentrated in hot pools and vents, forming increasingly complex webs of reactions. Eventually, those chemical networks crossed the threshold into life, the first self-replicating, cell-like structures. Early life evolved diverse metabolisms to harness available energy. Some microbes learned to harvest sunlight, converting light into chemical energy, the earliest forms of photosynthesis. These mats and microbial communities began to change the chemistry of their world. As photosynthetic microbes proliferated, they pumped oxygen into the oceans and atmosphere. Over millions of years, oxygen accumulated, radically transforming chemistry, enabling new metabolisms, and paving the way for more complex life, even while causing crises for oxygen-sensitive organisms. From single cells came cooperation and complexity. Multicellular organisms diversified rapidly in the Cambrian seas, experimenting with new body plans, shells, and strategies. This explosion of form established many of the major animal groups we recognize today. Earth's surface was, and remains, dynamic. Plate tectonics reshaped continents and oceans, driving climate swings and volcanic episodes. These forces triggered several mass extinctions and opened ecological opportunities that directed evolution's long path. After the extinction of the giants, vertebrates diversified into new roles. Mammals rose, experimenting with size and behavior. Over millions of years, one lineage of primates adapted to open environments, culminating in hominins, our direct ancestors, developing bipedalism, tools, and culture. Human ingenuity has reshaped Earth at an unprecedented scale, altering climates, ecosystems, and the flow of life. The future depends on choices we make now. Continued degradation, active restoration, or novel integrations. Understanding our origins helps inform how we steward this living planet forward.